So we're going to talk about section 1 from chapter 13, which goes over the distributive property and common factors. So we're going to talk very, very briefly about factoring in this section. Okay, factoring is when you almost do the opposite of the distributive. Distributive, remember, is when you had something sitting out front of a set of grouping symbols like parentheses or brackets of some type. You take that number out front and you multiply in. Factoring is when you undo that. So when you pull out anything that they have in common. So if you could take a 2 out of the terms, or it could even be like they have an x in common and you can take that out. So we're using a little bit of that GCF again, where you find like the greatest common factor that they have in, that you can then take out from all the terms to factor it. So the distributive property, like I said, is when, for this example here, you're taking a times x, a times y, and you get ax plus ay. So if a was that common term and I wanted to factor this, I would pull a out by dividing it. So instead of multiplying it, I would divide both of the terms, or however many terms there are, by that. So a common factor is just when something appears in each of the several terms, and like I said, it could be a number, or it could be a letter, or it could be both. In order to factor an expression, find whatever would be the biggest thing that they have in common. So if it's a 2, if it's a 3, if it's a 4, and then figure out if there's any letters that they have in common as well. If they have multiple letters, or if they have letters with exponents, and they share several of the same letter, then take out as many as you possibly can from all the terms. So for this first one, it wants you to write 3a plus 3b in factored form. 3 is in both of the terms. That's really the only thing that you could take out of both of them. So if I take the 3 out and kind of put it in front, what's left then is just the a and the b. So we write it as 3 times a plus b. So I'm just taking that 3 out front. What could you guys take out of the second one? 3. Do they share any letters? Like, do all 3 share any letters? No, the first 2 have A's, but 12 doesn't. And the first and the last have B's, but the middle one doesn't. So I can only, again, take a 3 out. If I take a 3 out, what's going to be left? (3a plus 4b). What was the first term you said? AB. So AB plus 3a plus 4b would be what's left after I take that 3 out. Okay, take a look at the next one. We've got 10a squared plus 6a. So look at your numbers 10 and 6. What's the biggest number that you could take out of both 10 and 6? 2, and they share an a, right? So if I take out 2a, what's 10 divided by 2? And then if I had a squared and I took 1 away, what's left? So 5a, and then what's left from the second term? 3. So 2a parentheses 5a plus 3. Okay, how about part B for this one? Take a 2 out, anything else? X squared. Now when you take 2x squared out of that first term, it's not a 0. What's anything divided by itself? 1. So make sure you guys put a 1 there. It's got to hold that place. And then it'd be plus 2x. Because 4 divided by 2 is 2. Remember, x to the third is the same thing as x times x times x, and I took out 2 of them. So I'm left with just 1. Okay, on the next page, can you take anything out of number 4? No. 2 and 3 don't have anything in common except for a 1, and they don't share anything out of x and y either. So, if this one's already written in factored form, you don't have, I mean, you could show me that you're only taking out a 1 if you really wanted to. That would look like this. But you don't really have to do that. It doesn't make anything change about this problem. So in this case, I would just write that it's already factored. Number 5, you have 7y times 2y minus 5 plus 3 times 2y minus 5. Do you guys notice that the pieces inside the parentheses are the same? Okay, so in Algebra 2, when you talk about factoring, you guys had to do a lot of factoring in Algebra 2 towards the beginning of the year. We talked about a specific type of factoring when you group terms together and you try to pull out whatever they have in common, and what's left over should match. So in order for me to write this factored, I have 7y and the 3. Those are like the terms sitting out front of the parentheses. I want those to go in its own set of parentheses, so 7y plus 3. Those kind of get grouped together, and then you just bring down the 2y minus 5. You don't need to write down 2 of the 2y minus 5s. You just need one of them to write it out as factored. Number 6, really similar to number 4. There's no number that I could take out of all 3 terms. There's no letter I could take out of all 3 terms except for like a 1. The only thing that you maybe might want to do, because that first term's negative, is take out a -1 to make the first term become positive. Again, it's going to look similar to what I did for number 4 there. It's just going to switch the signs of everything. Not really necessary, but it is possible to do that. It would maybe be helpful if you were actually trying to solve this, which we're not going to be doing today. But if you were trying to solve that, you might want that first term to be positive, so then you would just take out the negative to make it a little bit easier on yourself.